Today we are going to talk about the area of parallelograms, triangles, and trapezoids, and I will remind you of these shapes in case you've forgotten what they are, what they look like. I am using a new technology here, so it looks like my handwriting is a little bit messier. Just forgive that, please. Thanks. Okay, let's go ahead and let's just start with a triangle. So with a triangle, you might have something that looks like this. This is probably close to an isosceles triangle. Remember, isosceles means it has at least two sides that are the same. Okay, and that should be a vertical line, but that looks a little bit wonky. But that is my height. Okay, h is height. The bottom of my triangle is the base, and whenever you're finding the area of a triangle, again, just to remind you, it is equal to half of the base times the height. So you have learned this before. Your triangles may not be isosceles, they may in fact be scalene, okay, and the height might be noted on the outside of your triangle. So please just note that is, an imaginary line, but we do need to figure out what the height is of the triangle by taking its highest point and drawing a vertical line to its base so that they are in fact perpendicular, which means they form a right angle, and that would be the height. Another way to represent this formula would be to take the base times the height, multiply them together, and divide by 2. So either way works, just to make sure that you are, feeling good about this formula here. Something else to note in general, to remind you, area is always in square units. So each length would only be maybe in inches, but your area would be square inches. Centimeters and centimeters, your area would be centimeters squared or square centimeters. So just to make sure that area is denoted like this, units squared, but that is not true for your other lengths. I am just going to make that little note though that the height is perpendicular to the base. And that means it forms a right angle. Okay, let's go ahead and remind ourselves about parallelograms. Let's just choose a different color. Remember that in parallelograms, opposite sides are parallel. You might have a parallelogram that looks something like this, or it could be a square. And again, just forgive my drawings. These little tick marks just mean that all of these should represent the same length. Or it might look like a rectangle where these opposite sides are equal. Okay, something like that. In fact, I can also place those little marks here because in parallelograms, opposite sides are congruent, which means they're equal. Okay, and to find the area of any parallelogram, you just take its base and you multiply it by its height. So the area is equal to base times height. In a square or a rectangle, the base and the height are pretty obvious. The parallelogram, its base is also usually pretty obvious, but its height, again, would need to be marked, just like within a triangle, as a vertical line that is perpendicular to the base. Okay, so the height might be on the outside there. Now let's go ahead and review trapezoids. So with a trapezoid, just as a reminder, it has one pair of parallel sides. So it could look something like this. Okay, or it could look like this. Or I could even shift it on its side and have these be parallel. It could look like this. So just don't be concerned if you look at a shape like this and you're like, oh my gosh, that's not a trapezoid. It actually is because it has one pair of parallel sides, and we can use these little arrows to show which opposite sides are meant to be parallel. Something to note is that a trapezoid actually has two bases, and we can note these base 1 and base 2, and those happen to be the parallel sides. So it doesn't really matter which one you label, base 1 and base 2, okay? But they do have two bases. So here it would just look a little bit different. And the height is measured as the distance between the bases, and again it has to be a perpendicular line. So in this trapezoid I don't have any sides that are perpendicular to the bases, so I'd have to draw in the height h. Here you might not have been able to tell, but I did mean for this to be already perpendicular, so the height is actually the length of one of the sides of the trapezoid. Here I did the same thing, but I turned it on its side. So again, it's a little bit deceiving. The height actually looks like it would be a base, but it's not. This is the line that is perpendicular to both bases, so that would be measured as the height. The formula to find the area of a trapezoid looks like this. This is probably the one that's the hardest to remember, so you might want to double star it. But it's half the height times the sum of the bases. And remember, sum means addition. And these little 1s and 2s, again, these are just subscripts. They don't mean anything. I'm just distinguishing, hey, this is one value and this is the other. You add them together and then multiply by the height and divide by 2. So here is your formula to find the area of a trapezoid. I can box in the other one. And then here is the area to find the formula to find the area of a parallelogram, and this is what we will use all of these right now to do some problem solving. I'm just going to flip my page, and what I would like you to do is to go ahead and get out your handout, page 38, and let's just practice some of these together. You may use a calculator just to keep it simple. So let's go ahead and find the area of each figure. I would like you ladies to go ahead and try numbers 1, 2, 4, and 6 on your own right now using the formulas. Hit pause and then hit unpause when you're ready to see the solution. Okay, so for number 1, you are given the base, you are given the height, and it's a parallelogram, so you know the area is base times height, so all you have to do is multiply 10 and 12 together and you get 120 square meters. With number 2, we have a trapezoid, so I recommend always writing down your formulas first and then substituting the values you have in order to calculate what it is that you're missing. So let's go ahead and do that. We have a height of 13, so I'll put the 13 in for h. We have two bases, 3 centimeters and 7 centimeters, and I know that I need to add the bases together. And again, we are looking for the area. When you multiply all of these, you will get 65 centimeters squared. Number 4, we have a triangle. So remember with the triangle, it's half base times height. And this triangle has a base of 9.4 feet. I'm going to take half of that and multiply it by the height of 5 feet. And when you do that, oops, I was looking at the wrong one, sorry. Base of 8.5 kilometers and a height of 14 kilometers. I was doing number 3, sorry. And that would give you an area of 59.5 kilometers squared. And with number 6, we have a trapezoid, again, half height times the sum of the bases, and I have a height of 7 meters and bases of 6 meters and 9 meters, and when you calculate that area you will get 52.5 meters squared. Okay, let's take a look at some of the more interesting shapes because these are a lot more fun to do. So if you look at 7, 8, and 9, you're going to find the area of each figure. As you can see, each figure has been cut up into smaller figures. So for number 7, what two shapes do you see? you should see a parallelogram or a rectangle and a triangle, and you need to use the information you are given to find the total area. So if we start with number 7, let's go ahead and do this one together. I know I have a triangle whose height is clearly labeled as 3 centimeters. But what is its base? This isn't labeled as obviously as the height is, but if you look at the base and you look at the shape that's underneath the triangle, we have a rectangle. We know that that side should be equal to the side opposite. The side opposite is 10 centimeters. So in our shape here, if this is 10 centimeters, this is also 10 centimeters. Same thing, if this is 5 centimeters over here, we'll have 5 centimeters. Okay, let's go ahead and just find the area of that triangle since we now have its dimensions. So half base times height. You can do this in your head. Half of 30 equals 15 centimeters squared, but we're not done yet. That's just the triangle. So you might want to note that, that you have the triangle's area. Let's go ahead now and take a look at the rectangle. Well, how do you find the area of the rectangle? Well, it's a parallelogram. You do base times height. We're going to do 5 times 10. That gives us 50 centimeters squared. Again, this is the rectangle's area. And in order to find the total area, we will add these together. So 15 plus 50, and that will give us 65 centimeters squared. What I would like you ladies to do right now is to go ahead and complete numbers 8 and 9, and then I will give you the solutions and we will move on. So hit pause and please solve numbers 8 and 9. Okay, with number 8, you should get 26 square feet as your total area, and with number 9, you should get 384 square yards. Let's go ahead and take a look at some of the problems at the bottom. Here we have to find missing maybe heights or bases as opposed to area. So let me flip my page. Again, let's do orange. So let's take a look at number 14. And try that one together. It says a trapezoid. So again, trapezoid, you should immediately just write down the formula to find its area, since that's what we're working with. So it has an area, they're giving me the area, of 27.5 square centimeters. What is the measure of the height? So I don't know the height. I will leave that as h. If the bases measure 7 and 4 centimeters. So there are my bases. Now we've solved equations before. We definitely can work through this without a problem. Just make sure that you keep all of your rules in check. We need to add 7 plus 4. Keep it simple. You might even want to find half of 11 right now, because you can do that. What's half of 11? You know half of 10 is 5, half of 12 is 6, so 5.5 would be half of 11. And basically what I was doing here was I was simplifying one side of the equation, because now I'm just down to a multiplication step, and I can undo this multiplication step by dividing by 5.5. And again, you are allowed to use a calculator, so please go ahead and calculate. And you should get a height of 5, and then let's just check our units. 5 centimeters. This is not square centimeters because this is just a length. Lengths aren't square units, just areas happen to be square units. I would like you to go ahead and try number 15 on your own and hit pause. When you're ready to check the solution, hit unpause. Okay, you should get 18 feet. Thank you very much, and I will see you in class.